All right, this is our lesson 1.7 of Precalc 12. Unit 1 is called Functions and Transformations. Lesson 7 is called Combining Transformations. So far in this unit, we've learned 3 types of transformations. Can you name them? That's right, well done. We have translations, we have reflections, and we have stretches, and you nailed it. I'm proud of you. You're an awesome human being. Anyways, what we're going to learn in this lesson is how to interpret transformations between graphs and the function notation and working with all that kind of stuff. So just kind of putting it all together. So here are some functions with their expressions, and we're just going to pick out what kind of transformations can we find. So I tried color coding, so when you do transformations or translations, we're looking for adding and subtracting numbers. So it's all in green. And then when you have negative signs, that's what we're looking for reflections. So those are all in purple. And then any kind of stretch, whether it's a vertical or horizontal dilation, is going to be some kind of multiplier coefficient. That's going to be in red, or A value, if you will. So example A, we have a absolute value of negative 3x plus 5. Well, the negative in front of the 3x means we're doing a reflection. The negative is inside of the brackets right next to the x, so it's going to be a reflection of the x values, which means the x values are switching their sides across the y-axis. So it's a reflection over the y-axis. The 3 is on the x, it's being multiplied 3 times x. So that's inside the brackets, means a horizontal dilation, and our a value is 3. So then when we're multiplying, when we're doing horizontal dilations, you take the x value and divide it by our a, or 1 over a times x, either way. So that's going to be just, compressing it horizontally. Anyways, we have a plus 5 inside the absolute value symbol. So it's like a plus 5 on our input, so that means it's going to be a horizontal translation. Plus 5 means 5 units left. You can take a look at these. I think C and D are kind of analogous, and you can read those. B is a little tricky because the parent function doesn't use brackets. For B, the parent function is 2 to the power of x, which means instead of looking for what's in the brackets, we're looking for what's in the exponent. So the negative in the exponent means x's are being reflected over the y-axis, and the plus 1 in the exponent means horizontal translation, 1 to the left. All right, so we can take a look at, here's some more functions, but they're described a little differently. Unlike the last examples where we're given an expression, we're given 3 example functions, g, h, and j. And they're all described in terms of their parent function, f. And so f of x is described as x squared, so we have a parabola. In black right there is our base parent function, and its parent function graph. G, h, and j are all transformations of that parent function. So we're looking at f of x, and g of x, it's negative f of x minus 3 minus 3. So x minus 3 means we're horizontal translation, going 3 to the right. The minus 3 outside of the brackets means 3 down, vertical translation. And the negative outside is like a negative sign outside of brackets. So it's going to be taking the y values and flipping them over the x-axis. So that's a reflection over the x-axis. And we could read those graphs, or those functions, using function notation explicitly here, no expressions, except for x squared. And then we can relate those to their given graphs. And so if I take the parent function, I'm going to do my translations, or I'm going to do my reflections and my translations, and my stretches accordingly. All right, so some takeaways. We're now just kind of wrapping up our understanding of all the kinds of transformations that we'll be talking about. And hopefully we're making some connection between function notation, expressions, and then function notation in terms of other functions, and then connecting those to the graph and how the graph changes shape. And that's it.